Hello, and welcome to a brand new section of this course, Interactive Plotting and Graphical Interfaces. Let's get started with the first video of this section, Choosing a Plotting Backend. There are different ways to display a plot in the Jupyter Notebook. So far, we have created plots within the notebook using the matplotlib inline mode. This is activated with the matplotlib inline magic command in the notebook. Figures created in this mode are converted to PNG images stored within the notebook, .ipynb files. This is convenient when sharing notebooks because the plots are viewable by other users. However, these plots are static and they are therefore not practical for interactive visualization. Now, let's see an example. Add these lines and run it. So here's a graph with an inline backend image. Matplotlib can export figures to bitmap, that is PNG, JPEG, and others, or vector formats like PDF, EPS, and others. Refer to the documentation of plt.savefig for more details at matplotlib.org. You can also display a plot in a separate window on your desktop. This uses a GUI Backend toolkit that interacts with the operating system and the desktop environment to create and manage windows. Examples of cross-platform backends include Qt, WX, TK, GTK, and others. Matplotlib can use any of these toolkits to display a figure. Qt is a popular and powerful choice for GUIs. It is well supported by Matplotlib and Jupyter. To enable this mode in the Jupyter Notebook, use the matplotlib Qt magic command. This makes the notebook responsive while the pop-up windows are displayed, and it enables interactive modification of plots through the notebook. A related command is GUI Qt. It enables the creation of any interactive Qt window, not just matplotlib figures from IPython. Refer to this link for more information about GUI event loop support in IPython. Matplotlib figures displayed with a GUI toolkit are interactive. They support panning and zooming with the mouse. There is also a toolbar that gives you access to several functions. Let me show you an example. Matplotlib Qt, and we use the plt.imshow method. So here's the output with the Qt backend. Dynamic inline plots. Since Matplotlib 1.4.3, inline plots can be made interactive in the notebook through the NBAG backend. To activate it, use Matplotlib Notebook, or you can use this block of code. Note that you may need to restart the kernel in order to deactivate the previous backends. Simply go to Kernel and select the Restart option. As you can see that we got a warning message. You can pan and zoom in the inline plot. However, this sort of interactivity requires a Python server, so these plots remain static when displayed in NB Viewer. Now, the web platform has seen dramatic progress in data visualization technologies in the past few years. Although this has nothing to do with Python in principle, the fact that Jupyter Notebook is a web application makes it theoretically possible to leverage these technologies in the Jupyter Notebook. For example, the MPLD3 project automatically converts a matplotlib plot into a JavaScript D3 interactive visualization. If you don't know about that, let me tell you. So, D3 is a JavaScript visualization library that runs in the browser. We'll see it again later in this section. It's very easy to use. You can install it with pip install mpld3 command in the terminal. Now, to import and enable it, add these lines of code to the next cell. And here's the output. Then, matplotlib figures are rendered with D3 and support panning and zooming even in NB Viewer. To learn more about d3.js, you can visit d3js.org. And for MPLD3, go to this webpage.